This is for section 5.3, and this is part 1, and today we're focusing on the double angle formulas. We're going to use these formulas when we have 2 times a theta, so 2 times an angle. For example, the sine of 2 times pi over 4. This would be an example of when we could use a double angle formula. If you look for a minute at these formulas, you'll notice that cosine has 3 different formulas. You have 3 options, and really you're going to pick which one to use based on the information you're given, but you have 3 different options there for the cosine formulas. So let's go ahead and take a look at our first example and see how we can find, how we can use these formulas. So we're given the value of sine being 3/5 and our angle being between pi over 2 and pi, so it's telling me we're in quadrant 2 here. And we want to find the exact value of the sine of 2 theta. So we're going to use this first formula. Now, in order to find the sine of 2 theta, I need to know the cosine of theta. That means that we're going to have to go back to what we learned in chapter 4 and draw a triangle in quadrant 2. Theta, remember, is in the inside. We have sine. We're given sine, the opposite over the hypotenuse, so 3 and 5. That makes this one a 3, 4, 5 right triangle, and we know the 4 is going to be negative because it's going negative along the x-axis. The great thing now about this picture is I, in fact, can get the cosine of theta to be negative 4/5 adjacent over hypotenuse. Again, we also know the sine theta to equal 3/5, and that's from the given information. I now have everything I need to find the sine of 2 theta. Remember, the formula says the sine of 2 theta equals 2 times the sine of theta times the cosine of theta. Let's plug in what we know. We know sine theta is 3/5. We know cosine theta is negative 4/5. I just have to do some multiplying now. Remember, this is like 2 over 1. 2 times 3 is 6. 6 times negative 4 is negative 24. And 5 times 5 is 25. So we get negative 24/25, and that's the value of sine of 2 times the angle theta. So whatever theta is, if I double it, the sine of that value is negative 24/25. Let's go ahead and try another one. We have tangent of theta equals 1/2, and I want to find the exact value of the cosine of 2 theta. Now, we're given that theta is between pi and 3 pi over 2, so that's going to be in quadrant 3. If I'm finding the value of cosine, I have some options here. I can use the first formula where I use sine and cosine, the second one where I use just cosine, or the third one where I just use only sine. Now, I'm going to pick between these, and in this case, I'm going to pick the one where I use only cosine. The reason I didn't pick the first one is because then I'm going to have to find sine and cosine. I just want to find one of them. And so really, either of the second 2 would work. Let's go ahead and draw a picture. And let's put our theta down here in quadrant 3. And we're given tan, so we're given opposite and adjacent. And they're both going to be negative because in quadrant 3, x and y are both negative. And we need to do the Pythagorean theorem to find the hypotenuse. So negative 1 squared plus negative 2 squared equals our hypotenuse, or our radius squared. And we end up with that radius, or that hypotenuse, being the square root of 5. Now that I have that information, I can go ahead and find the cosine of theta to be the adjacent side, negative 2, over the hypotenuse, root 5. If I rationalize that and multiply the top and the bottom by root 5 over root 5, I get negative 2 root 5 all over 5. The reason I found cosine is because I'm going to use the second angle, the second formula there. If you wanted to use the third one, then you'd be finding sine instead. And if you wanted to use the first one, you would be finding both sine and cosine. Now that I know cosine, I can find cosine of 2 theta. That's going to be 2 times cosine squared minus 1. I'm going to plug in what I know, and I know that cosine is negative 2 root 5 over 5. And I'm going to have to square that, minus 1. Now, to square a fraction, you have to square both the top and the bottom. When I do that, and I square negative 2 root 5, negative 2 squared is 4, and root 5 squared is 5. When I square the bottom, I get 25. If I keep going, I'm going to have 2, or 2 over 1, times 20 over 25 when I multiply, minus 1. If I multiply the 2 in, I'm going to get 40 over 25. And common denominators tells me 1 whole is 25 over 25. If I subtract those fractions, I get 15 over 25, and that simplifies to 3/5. So the cosine of my double angle would be 3/5. Now, let's go back for 1 second. You'll notice that I put the rationalized form into my formula. Had I used the unrationalized form instead, it would work out almost the same way, only the squaring would have been a little bit easier. And let's take a look at that just really quick. If I want to square negative 2 over the square root of 5, right off the bat, we're going to get 4 over 5 when I square the top and the bottom. So I'm going to get 8 over 5 minus 1, which is 5 over 5. And it turns out to be 3/5. So you can see had we used the unrationalized form, this time around it actually would have worked out a little bit better, a little bit easier. Either way you go about it though, you'll get the same answer in the end, that 3/5. Let's actually go back one more time to this same question. And now, if I wanted to find the tangent of 2 theta, I could also do that, knowing that the tan was 1/2. Let's go ahead and bring that up. One more second. Let's change this question just a little bit. Let's find the tan of 2 theta, just so we've done a tangent example as well. If I want to find the tan of 2 theta, I'm going to go ahead and use the 2 tan theta over 1 minus tan squared theta formula. And I already know what the tan of theta is. That was given to me in the question, 1/2. So we're going to get 2 times 1/2 all over 1 minus 1/2 squared. And now really we just have to simplify some fractions here. 2 times 1/2 is 1 over 1 minus 1/4 when I square the 1/2. In the denominator, I'm going to change my 1 whole to 4/4. So we get 1 over 3/4. And dividing by a fraction is like multiplying by the reciprocal. So our answer in this case would be 4/3. All right, we have 2 more examples. Here's the next one. Find the exact value of 2 times the sine of 22.5 degrees, the cosine of 22.5 degrees. Now, the problem is that 22.5 degrees isn't on our unit circle. So let's just take a look for a minute. This is the same thing if I think of these 22.5s as thetas as 2 sine theta, cosine theta, because they're the same angle. Now, to me, that looks like the sine of 2 times theta. So I can rewrite what we're given up here as the sine of 2 times 22.5 degrees. Now the nice thing about that is 2 times 22.5 degrees is 45 degrees. If I just continue on, 2 times 22.5 is 45 degrees, and I know the sine of 45 degrees, that equals root 2 over 2. So working the formula backwards, I was able to get my answer. The last thing, our favorite, verifying identities. We're going to add these double angle formulas to our list of options for verifying identities. Now, if I look at this, the left side and the right side, to me, the right side looks a lot more complicated. So we're going to work the right side for a while. And I see the cosine of 2 theta. So we can go ahead and switch that using one of our formulas. Now, it's a cosine double angle one, and I have a lot of options. Let's just start with, we're trying to get sine in the end. Tangent. Let's just start with the bottom one. Now, I don't really know for sure which one to start with, so we're just going to pick one. 1 minus 2 sine squared. So we'll have 1 minus 2 sine squared theta. The nice thing about the sine formula is I only have one option here. If I distribute the negative on the top, I get 1 minus 1 plus 2 sine squared theta all over 2 sine theta cosine theta. I think we're getting close. 1 minus 1, that equals 0. So that goes away. Now I just have 2 sine squared theta. And let's write that as 2 sine theta for a minute. All over 2 sine theta cosine theta. The 2's are going to cancel, and so are one of the sines. I'm left with sine over cosine, which equals tangent. Now we got lucky this time that we picked the right cosine formula right away. Had you picked one of the other ones, it might not have worked as easy and you might have had to gone back and do a little bit of work. But in the end, you should be able to get down to tangent of theta. That's where we're going to end this video, and we're going to practice this in class the next time I see you.